The final challenge question was one of our like derivation ones that we talked about. We did this for tangent. We did not do this for cotangent. I'm trying to change to blue. Um, Come on. So let's go ahead. This says you find this using only the derivatives of sine and cosine as known. So that means we can't just be like, well, we know cotangent. So the first thing we need to do is rewrite cotangent as cosine of x over sine of x, right? Use that quotient identity. And then we need to use the quotient rule. So derivative of the first, low. My God, I'm wrong. I can't just, it's like, wait a minute, that doesn't make any sense. Low, there we go. There, I'm back now. D high, so be negative sine of x. Remember, we need parentheses here to make sure that looks like division and not subtraction, or multiplication, not subtraction. Minus high, D low, all over low low. Okay, so let's clean this up a little bit. We have a negative sine squared of x minus cosine squared of x all over sine, oops, squared of x. And so we have two ways that you can really finish this question up. Well, lots of different ways, but what I'm going to do, because it's just the way my brain works, I am not going to split this into two fractions. I saw a lot of students do that, but we can do this. I'm going to pull a negative 1 out, and I'm going to leave behind a sine squared x plus cosine squared x all over sine squared x. So I'm doing this because I think most of us, this version of the Pythagorean identities is the most common. It's probably the one we know. This we can recognize as 1 and rewrite this as sine squared of x under that negative 1, right? So this is negative cosecant squared x. So we're back to where we said, let's go. All right. You could have also taken an alternate version here. Hold on. Boop. We could have split this into two separate fractions. This is negative sine squared x over sine squared x minus cosine squared x over sine squared x. That's a negative 1 minus cotangent squared x. Then this, I'm sure there's some Pythag identity, right? If we'd taken that original sine squared x plus cosine squared x is equal to 1, Pythag identity, divided everything by sine squared of x, we would realize we have 1 plus cotan squared of x is equal to cosecant squared of x. And so if we multiply all of that by negative 1 on both sides, we end up with, 1 minus, that's what we have here. So this is equal to negative cosecant squared of x. A different way to get there, right? I think the first way was a little bit easier, but your brain might have wanted to immediately divide out that sine squared, in which case you wouldn't have ended up on the second path, but you should have still been able to get to negative cosecant squared, especially knowing where we were going, right? We know the answer, we know where we're headed, so it's a question of how can we get there. And one of the things that can be really helpful in a question like this when we're trying to derive something and we know the start and we know the end is to sort of rewrite this and be like, okay, well, cosecant is sine. Can I end up here at some point? Like, your goal is maybe not straight to cosecant, but to 1 over sine squared. And so you're already seeing, okay, there's a sine squared. You're feeling good about where you're headed on this path. But if you see that goal of getting to a sine squared, that hopefully makes you realize, can I rewrite this as a negative 1? Is it possible for that to equal negative 1? So you're in that path and that mindset of where you're headed, as opposed to just sort of blindly moving forward.